All right, so our approach to GMAT preparation, what makes our students more successful? Well, it's the methodical approach that we are very proud of. We don't give shortcuts because they don't work every time. It's a methodical approach that you will learn to apply, which will work everywhere forever. So it's one thing you learn and then you have it forever. So agenda for the session is going to be solving number properties questions using a unified approach. It's not going to happen that every new question you see, you have to start thinking all over again. Okay, now what is it that I have to do? One unified approach based on the concepts that this topic covers, and you will be applying all of those. As I said, I am your presenter for the day, Shweta Kochija, and Atreya Roy is going to support us. Now, the purpose is to help you understand that the key to acing GMAT is two things: sound understanding of basics. Nothing can compensate this. You have to have your basics ready and a structured approach to solving questions. There are people who know the concepts but don't know how to apply those concepts. They just can't get things together. Here you learn that approach to solving questions. Now, here is the progression of the session. Everybody make sure you pay close attention to this because this is very important. In the beginning of the session, I'm going to show you three questions, data sufficiency questions, 700 plus levels, so hard questions. And they're numbered 8, 9, and 10. Why? Because they're actually supposed to be here at the end of the session. Let me tell you why we're bringing them here up front. This is to show you the goal of the session. This will show you what is it that you're aiming towards. What is it that you will be able to solve after the session today is done. So here you'll just solve these, but we will not discuss them because we will not have all of those tools in our arsenal to be able to solve this. This is just to give you a flavor of what we are getting into. To really start learning, warm up section is the first one where you're going to have less than 650 level questions, just two of them, one and two. Then you will have problem solving questions, three 650 to 700 levels. So you see it's slightly higher level than the warm up. And this time questions one, two, three, just three questions here. Then the next four questions are again problem solving, but hard ones this time, 700 plus level. So overall, warm up is this much. This is just to warm you up. These two sections, problem solving 1 and problem solving 2, these are where we solve 7 problem solving questions with increasing difficulty. Finally, we'll solve the first three questions that we're going to see right now here, questions 8 to 10. And by this time, you will be ready to solve these three questions. And what we'll see is that your accuracy in solving these will greatly change from when you're solving this the first time, which is going to happen in a minute, to when you solve it finally after you're done with the session. So I'll just bring in the yes no poll. Please tell me if you understood the progression of the session. It's important you know what's going to come. Here you go. All right then. Perfect. Thank you. So here we go. GMAT style questions, 700 plus level, which I said is where we're going to start. Get your pen and papers ready. Here is question number one, but one thing before that, some house rules. So in the poll that you have, you need to mark still solving to show me that you're ready for this. When you mark you're ready for the question, only then do I show that to you. And the moment 80% of these ready people mark their answers, I will start discussing the solutions. Well, you know, the first three we're not going to discuss, but this is how you people will direct the pace of this session. All right, so here I have still solving from about 61 people. We have 143 participants. Make sure you all are engaged in this. The more you interact, the more you're going to benefit from this. All right, good. The numbers increase fast. Here's your first challenge question. Question number 8. Good luck. Ending the poll in 10 seconds. Please make sure you mark your answers by then. Never, never leave a question if time is running out. The GMAT penalizes you more heavily for missing a question than for getting it wrong. All right, so I've ended the poll. Let me show you how you guys have responded. I'm not going to tell you the answer yet because we have to solve these, but just see how you are divided mainly between C and A. The majority went with C, then A. B, D, and E had kind of equal votes. Overall, C took the majority vote here. We don't know what is correct, but we can see that the group is not confident as a whole. There is a lot of variations, especially between C and A. Okay, with this now, I'm going to clear this poll up. You just mark still solving to tell me that you're ready for the next challenge question, question number 9, and then I'm going to show that question to you. Just a second. All right, the poll is now open. Okay, good speed. Here's number 9, everyone. Good luck. Ending the poll in 15 seconds. All right, then. Here are the results. Just broadcast them. Just look how this time we are even more confused. In the previous question, number 8, we had at least a close match between A and C, and B, D, and E were really losing big time. This time, it's more scattered. A and C are at a tie. E is 17% of you, D is 12%, and B is the one that got the least number of votes. But again, very, very divided vote. We are not sure of what we are doing. So again, that is natural. Do not get worried or anything. But then this should make you more excited that by the end of the session, these are the very questions you will be able to solve. I'm going to clear the answers, reopen the poll. Tell me you're ready for the next one. All right, here we go. Good luck. Ending the poll in 10 seconds. All right, so here are your responses. You can again see A, B, C are all at a tie. They're almost the same number of votes. D is at a majority, a slight majority, 31% of you went with D. And E got the least number of votes, which is again something, 10% of you went with E. All right, now before we move on to the warm up section, which is what you know is coming up, I am opening the chat pod, which is where you and I talk. Tell me how you feel about these three questions that you just saw. How were they? How many could you do? Very tricky, challenging, confused, not confident. Good questions. Tough, tough, tough. Tricky, super hard. Okay, so a bit lost. Very lost. No idea about them. One person says easy. That's wow. Mostly all of them are based on unit digits principle. Well, we'll get there. Always confused between two choices. Not confident with a lot of exclamation marks. No clue about the third one. Okay. So all of you can read this chat and you can see how the group as a whole is struggling with these concepts. And this is a concept, this is a topic that stumps a lot of people. Trying to recall basics is one of the comments. Well, that is what exactly we'll try to do here now through the warm-up questions. I'm glad I understand how the data showed me the picture that your messages do, the percentage of the votes they told that we were not comfortable with this topic, and now we all know through the messages as well in the chat box. All of us now, let's take the first step towards getting comfortable through the warm-up section. As I said, warm up section is going to be easy questions. We're just going to warm ourselves up. This will have the basics questions, the basic questions on DNR. And as somebody just said, trying to recall basics, this is your place. You'll be seeing basics here. So you will get a feedback about where you currently stand in terms of your conceptual knowledge. How much is it that you still have to build? There will be solutions to this, and through those, you will be learning the warm up, the concept. Let me first change the poll. One second. All right, so I'm going to show you the very first warm-up question. The moment I have enough people say, come on, bring up the numbers. Right now, I just have half of the people here saying that they're ready. Everybody remember that if you mark still solving, only then do I count you as an active participant in the session, and only then can you drive the pace. All right, good, good. Here is warm-up question number one, everyone. Good luck. Sorry about the poll, everybody. It had three options earlier, while the question actually has four choices. Please mark your answers again in case you already had done. All right, now I have a lot of votes here this time. I gave you a lot of time for this one. I wanted all of you to vote. This is how you people have voted. We have 82% of you going with option D, and then very few people with A, almost not nobody. B and C, yeah, B and C took the next. C was 12% and B was 5%, as we saw here. Now, this question, you had a lot of things, a number n, which you didn't know, which left a remainder of 10 when divided by 144. And the question was, what is then the remainder when n is divided by 12? Now, this question, I don't know if you felt so, but this is not really the first stage of beginning this. The very first stage will be when I tell you something about divisibility, something about how do you check when a number is divisible by 3, how do you check when a number is divisible by 4. Divisibility tests is what you call them. And then, of course, this is what comes next. Let me discuss this. I will also talk about those divisibility rules. Let's discuss this solution together. Look, this box here, this concept, this is the star of the show today. I will be stressing on this a lot. And this is the first question where you are going to see that. Look very closely. Dividend, the number that you divide by something. Divisor is the number by which you divide. You have a relationship between these two. Dividend is equal to divisor multiplied by quotient plus the remainder. This is always going to work. Just check any division in the world. Maybe just divide 15 by 2. And you're going to see that 15 is the dividend, 2 is the divisor, the quotient will be 7, and the remainder will be 1. It will always, always satisfy this relationship. So this is a relationship you might have learned in school, but now you'll see its true power here through this question. What we're given in the beginning is that number n, when divided by 144, leaves a remainder of 10. So that means n is your dividend, 144 is your divisor, and the remainder is 10. You have no idea about the quotient. Well, you don't know the dividend either, but at least you have a name for that. You know it's n. Let's call the quotient q. What I used was this relationship, this concept here, the divisibility and remainder equation, or let me just call it the DNR equation. So I use the DNR equation to write this down. And what my question wanted was, what will the remainder be if it is divided by 12? That is, the dividend is still n. The divisor is 12. You don't know the quotient, you don't know the remainder this time. But at least I've used the same DNR equation to write this relationship down, where now I have three unknowns. All I know is the divisor is 12. And one more thing here. Always remember, you never stop division unless the remainder gets smaller than the divisor. So this r here has to be smaller than 12, otherwise you'll keep dividing, right? Now, what am I going to do with this? I'm sorry about. Please give me 1 second. All right, let's resume. So how am I going to go from this session, this step 144 to this one that I want here? Look, the divisor here is 144, but the divisor that I want is 12. Look closely. If you see 144 is 12 times 12, right? So I can express 144q as 12 times 12q. Now this 12q will become the p that I want here in the second equation. So if I use this, I can just write n is equal to 12p plus How much? This 10. I'm not changing anything else, right? It's the same first equation that I'm using to re-express 144 as 12 times something. So the remainder that I get is r, which since it is less than 12, I am done. So the majority here got this correct. So I'm very glad to see that the basics of using this equation are good for you. But I want to make sure how exactly you people did this. So come into the chat box now, answer my question. Tell me, was this the approach that you used? And if not, tell me what you used. So a lot of people said yes, that is, this is the method they used. Somebody says I used examples. Good. So yeah, so that is what usually people use for the first time, just assuming numbers. Assumed q equal to 1. Yeah, so some people used numbers, plugged in values, and some people used this approach. For those of you who did not understand the approach yet, do not worry. We're going to see a lot of questions on this. But right now, I'm glad to see that some of us already know this approach of the DNR equation. Even the others who used a different approach, did you do this properly? Did you do this? The approach that you used, was it exactly this? And otherwise, were you sure of the approach that you were using? Okay, I'm glad to see all of those yeses. Just one person, one no I've gotten till now. But don't worry. So, everybody, this gives me an idea of where we are going with this topic and how comfortable we already are with this topic. Let me just start this now. We are now going to officially start the warm up section. Just give me 1 second. I will bring in the warm up section here. All right, so you should be able to see the screen again, which says warm up section. And this is now when we're actually going to start the warm up. That one question, I decided to bring it before the warm up to just, test the waters a little. Now I'm going to begin the warm up section. This time it's going to have three choices. That is actually the poll that I had brought in the first time. Here is the three choice poll again. Please mark still solving to tell me you're ready. And let's have the first warm up question. You'll feel it easier because we're now going back. There you go. All right, great here. So 67% of you went with option B, which is correct. So the majority got this correct, but 22% of you thought that this is A. So that means this is a very, very basic level question, and this is something that we're not absolutely sure about. So let me discuss the solution. And this concept, and whatever you learn from any one question, make sure you take it to the next question because otherwise you are not going to see the growth that you're looking for. So here, what do we have? Z is a three-digit number whose digits are consecutive numbers. So consecutive digits in increasing order. So you have the smallest digit first, then the next one, and then the next one. And you have to select the correct statement based on that. Look, first of all, the divisibility rule that you should know is this. If any number is divisible by 3, then the sum of its digits should be divisible by 3. Now, why am I looking at divisibility by 3? Because look at the options. All of them are talking about divisibility by 3. It may be so, it is always so, or it's never so. So divisibility by 3 is the core idea that we're testing here. And the test, as I just said, is just to check the sum of the digits. Now, because I know it's going to be consecutive numbers, if my first digit is x, my second digit is x plus 1, and my third digit is x plus 2, since they are in increasing order. Otherwise, I would not know which one is x plus 1, which one is x, and which one is what. However, the sum would still not matter. Now the sum here is 3x plus 3, which is 3 times x plus 1. Of course, this is divisible by 3, right? 3 times x plus 1 is divisible by 3. And therefore, the sum of these digits is divisible by 3, always divisible by 3. And the answer, therefore, is choice D. Now, for all those of you who marked A, please tell me in the chat box why you thought it is maybe divisible and not always divisible. Waiting for responses from 19 of you who marked option A. Why did you think it was maybe divisible? Was it because you were not sure of the concept and you just randomly marked an option? Or how did you approach this? Every single person, use every single question as something by which you learn more about yourself. Okay, somebody says selected the choice incorrectly, did not use the method. It's okay if you didn't use the method. That means it was a random option you marked, right? Took negative cases, question did not mention positive. How could you take 101? It's consecutive digits. Your digits are not consecutive. It should have been 1, 2, 3, even if you took negative. Selected by mistake, forgot about the rule. So some people do not know the rule. And of course, if you don't know the rule, it is going to take time and it is highly likely that you're going to get this wrong. And all right, -1, 0, 1 are consecutive numbers. Yes, whose digits are consecutive. So here's a big problem. Let's clarify this right now. Whenever a question says digits, the digits can only be something from 0 through 9. Negative numbers are not digits. -1 is not a digit. You don't call it a digit. And that is why you got this wrong. Yes, they're consecutive numbers, but you don't call them digits. All right, so I'm glad everybody is on the same page now. Next up is going to be another small divisibility test that you're going to learn. This one was about 3. Next one is going to be about 4. So Mark's still solving, and I'm going to show you the next one. All right, here you go. Good luck. Ending the poll in 5 seconds. All right, so we can see the majority went with option A, which is correct. So that's very good. But then a lot of you went with option C, 42% of you. Now, for a 51% majority, if 42% people mark something else, that's again a huge, huge percentage. That means we are not very sure again about the divisibility rule for 4 as well. Let's see. And also A and C. A says it may be divisible. C says it's just not divisible. So very few people thought it is always divisible. Let's discuss this. So Z is a four-digit number. Digits are consecutive numbers. So yet again, you can think of it as x, x plus 1, x plus 2, x plus 3. But the nature of the divisibility test will tell you that you should think differently. Look, what is the divisibility rule of 4? The divisibility rule of 4 is that the last two digits of the number should be divisible by 4. So if it's a number, it's 4 digits or 24 digits or 3000 digits, whatever the number may be, all you need to check is the last two digits. If the number formed by the last two digits is divisible by 4, then the entire number will also be divisible by 4. Now look here, all we know is that all four of those digits are going to be consecutive. Look at this, 2, 3, 4, 5. They are consecutive. And the last two digits form the number 45. Because it is odd, it can never be divisible by 4. It can happen in other situations as well, right? So you could have in the end 6, 7, or you could have 8, 9. None of those are going to be divisible by 4. But in the case Z is even now you're not sure about the last two digits. For example, 3, 4, 5, 6. Now 56 is divisible by 4, so the entire number will be divisible by 4. But 34 is not divisible by 4, and therefore 1, 2, 3, 4 is not divisible by 4. So here you got a maybe divisible by 4. It's a yes sometimes and it's a no sometimes. For all those of you who said it is never divisible by 4, you missed this case with 5, 6. Tell me you understood this in the chat box and what is it exactly that confused you in this question? Okay, so some people said, again, did not know the divisibility rule. Took the same three examples, that's good. This is hit and trial. No, it's not hit and trial at all. You're just looking at the last two digits. So just think about 12, then 23, 32, 34, then 45, then 56. Think about it. Which ones can be divisible by 4? Which ones are divisible by 4? Followed the rule for 3. Well, we have different rules for 3 and 4. Then, okay, somebody else did use the same rule, a plus 1, 2, and 3, and then you just added all of those digits. That is not the rule for divisibility by 4. It's not the same rule. Somebody thought that the last two digits separately should be divisible. No, it's the number formed by the last two digits which has to be divisible. So good. A lot of you forgot the rule, and that is why this happened. So I'm glad now everybody knows the rule for divisibility. And so whenever you're going to see another question, you are going to be more comfortable with this. So great then. Next up is question number 3 in the warm up. I'll just clear the poll. You just have to tell me you're ready by marking still solving. All right. Here's question number 3. Good luck. Ending the poll in 5 seconds. We again had the wrong poll. 4 choices coming up. There you go. Please mark again one more time. Sorry about this. All right, here we go. So 97% of you marked option C, which is the correct answer. So I'm glad all of you people were marking C in the previous one also. Thankfully, luckily the answer was the third option. So all right, so what is the number closest to this, which is a multiple of 8? So this time you need to know the rule for divisibility by 8. You need to understand when is it that a number is going to be divisible by 8, or when is it that a number is going to be a multiple of 8. Okay, now this time just it's similar to what you have for the divisibility rule of 4, but instead of the last two digits, you now look at the number formed by the last three digits. That number should be divisible by 8. Now, right now you have 897. When you divide 897 by 8, just to see is it already divisible or not, you would realize it's not already divisible. You get a remainder of 1, which means this is one more than a number which would be a multiple of 8. So what is that number which is a multiple of 8 then? 896. So all you need to do is change the last 7 into a 6, and that is what you have here in option C. So all of you got this correct. Were most of you got this correct, or was it because you could see the results? Tell me if you were aware of this divisibility rule in the chat box. Okay, so many of you say yes, 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 you were aware of the divisibility rule. Many of you say no as well. So for all those of you who saw on Google, you're Googling alongside this, you're not supposed to. This is where you'll understand where you're faltering or what are the concepts you are missing. I'm going to tell you, of course, so you don't need to Google alongside this. All right, next up is warm-up question number 4. Again, you are going to have four choices. So just mark still solving, and then I'm going to show you the question. There you go. Good luck. This is similar to the one question we solved before these three. Try using the DNR equation that I talked about in that question. Dividend is equal to divisor times quotient plus remainder. Ending the poll in 10 seconds. All right, so here are the results. Very good results this time. It's just that 20% of you never marked the final answer. Otherwise, the people who did mark the answer went with the correct option with D. So really, 80% of you voted, and from those 80%, 67% went with D. So that's great majority. A, B, and C got very, very few votes each. So let's discuss this one. Again, for those who had not understood the DNR equation, now is the time to understand this. So you have a dividend n. You know the remainder is going to be 3 if I divide n by 204. That is when the divisor is 204. Then they ask, what is the remainder? If the same dividend is divided by another divisor, which is 4. Now the relationship that we know is this: dividend is equal to divisor times quotient plus remainder. So first you're going to write this DNR equation for the given information. Dividend n, remainder 3, divisor 204. So put everything in place, and the only thing I don't know is the quotient, so I'm just going to call that Q. And then write the DNR equation for what you want. You want the remainder, dividend is n, divisor is 4. So here you write the DNR equation. R this time is what you want to find out. Always remember, the remainder is always going to be less than the divisor. So it has to be less than 4, right? Now what do? This is the given information, n equal to 204q plus 3. This is what I want. So from what is given, I want to go till this, what I want. What I really have to do is change this 204 somehow into a 4. Now it's very simple because 204 is just it is a multiple of 4. How am I so sure? I'm just looking at the last two digits, 04. 04 is of course divisible by 4. So 204q can be written as 4 times 51q. Now this 51q as a whole becomes p for us. So this is how it will become 4p, right? So if I just substitute it that way, it's going to be 4p plus 3. Now when I compare it with this final equation that I want to go into, r is equal to 3. And this one works for me. Why? Because r is less than 4. That is the only condition that my remainder has to satisfy. And also that it cannot be negative. It can be 0 and it has to be less than the divisor. So that is why the answer for this one is option 3. Option D, which is 3. Now, a similar example on the same lines, you're going to see warm up question number 5. I want to see a higher majority this time getting question 5 correct, because we are going to apply the very same principle. And this time, it's going to be the third time for you. So, mark still solving and get ready for question number 5. Aim for an above 85% accuracy this time. All right, then. Here's number 5. Good luck. Ending the poll in 5 seconds. All right, so here are the results. I did not get the majority I was expecting, but it's only because of a very, very, very small miss, something that you had to do at the last stage. If only you had taken care of that, the 28% who marked option D would also have been with A. And in that case, your total accuracy would have been 90%. Oh, well, more than the goal that I was looking for. Let's understand this. Let's talk about this. And then once you learn about this, never, never forget. Make sure you take your learnings from one question to the next. So it's exactly the same way I'm going to start the DNR equation for the given information. N is the dividend, remainder is 6, divisor is 205. So here's the DNR equation for quotient Q. Then I want the remainder when n is divided by 5. So this time it's this r that I want. You forgot the rule that r has to be less than 5. I said this so many times. The remainder always, always has to be less than the divisor. When you worked on this, the usual way, the method that you learned in the previous questions, you will come to r equal to 6, which is what you saw in option D, and 28% of you just marked that D. But this is where difference came. Some of you, 62% of the group then, did not stop here. They did remember the rule that the remainder has to be less than 5. Well, what do you do in such cases when the remainder comes out to be more than what is allowed? In these cases, you will apply the DNR equation one more time on this 6 as your dividend and 5 again as your divisor. The divisor does not change. Or you can think of this as dividing the remainder that you get by the divisor to get the final remainder. So when you do this, 6 is equal to 5 times 1 plus 1. So really the ultimate remainder that you leave is 1. Or you can think of it as 6 divided by 5 will leave a remainder of 1. This is where the group was differentiated here. I'm very glad that the majority thought correctly, but I would be very, very happy, would have been very happy if everybody remembered this one rule. So every little thing that we say, we learn here counts. It's important. Just because you saw me in the previous examples, you saw me just leaving this last remainder as the final answer, you did not take this forward this time either. But remember the rules. All right, with this, we are done with the warm up section. Make sure you are 200% clear about all the concepts, the divisibility rules, how the DNR equation works, how you write the DNR equation, how you use a given DNR equation to get to what you want. If you scored less than 100%, that means even if you got one question incorrect in these, make sure you revise all of this again. You are going to get a recording of the session today. Use it. You're going to get the PPT as well, the PDF. Make sure you go through the concepts, watch the videos we send your way, and cement all of this understanding. 200% clarity is very important because the GMAT is going to ask you questions at a higher application, at a higher level than what you saw here in these 5 warm up questions. I'm going to open the chat box now. Tell me how you feel about the warm up question. What has been your biggest takeaway till now? What has been your biggest takeaway? Things that you did not know before the warm up and now you know them. Things that are now going to help you in questions that will come up. Fundamental rules. Don't jump steps. Yes, go with the process. I'm glad you learned that very early into this. Divisibility rules. Fundamentals work every time. That's true. Refreshed my mind. The approach is great. I'm glad you appreciate this. It's going to help you in many, many questions to come. Very difficult questions will become super easy with this. Going good so far. 8 to 10 overwhelmed me. Don't worry. 8 to 10 is what we're preparing you for. Don't worry at all. Why do we treat remainder as dividend? Well, we further divide the remainder by the divisor just so we actually see the part which is not divisible by 5. Remainder is what remains. Did not know the rules. Important to learn different rules. Thanks for the DNR approach. Yes. Don't be hasty, even if the question looks easy. That's important. Being hasty, you might lose the 1 minute or the 1.5 minutes that you already spent on a question and get the wrong answer. Concepts matter. Oh yes, concepts matter the most. It's the foundation on which you're gonna build everything else. If you don't have concepts intact, you will certainly stub your toes somewhere. That's so well put. Well, I'm very glad you all understand the importance of concepts, and a lot of you now know concepts that you did not know earlier. With this now, let me talk about something, a study plan. Well, all of you right now, when I asked how you felt about this, and when I had asked about the 8 to 10 questions that we did in the beginning, some of you said you found them easy. Some of you said you absolutely had no idea what to do. See the variety when you are just 160 people here. Now think about all of you doing this at once and many, many more people taking the GMAT. Not everybody starts at the same place, right? We all have different starting points. We all have different targets. So you need a plan that suits you the best, your plan. So you have to have personalized milestones, what you have to cross to get closer to your target score. You need precise estimates of how much time you need to spend on a certain subsection based on your current comfort with it. You need to be able to track your improvement while studying. You have to know whether you're going in the right direction or not. To help you with all of that, Atreya just shared a link about a GMAT study plan. You go to that link, you have to just choose the tile which matches your problem area. For example, highlighted here is timing issue. So this is for people who are just struggling with time. Say somebody is here who just needs a foundation, not comfortable with the very concepts, then select this. Somebody who's stuck at 640 despite a lot of effort, select this. So choose your tile. After that, click on this button where it says help me reach my target score. Then you'll see this screen. You just have to choose a convenient slot, whatever time works for you. Select that. And now fill out your this small form which is about details, your target score, your name, email ID, of course. This is something that will help us understand your needs, your preparation. So what's your target? Where are you currently at? Where are you struggling? What do you find easy? What do you find difficult? So this will help us prepare for our discussion with you. So if you're already an e-GMAT student, you should have your own personalized study plan. You should be able to understand the plan, not just having a plan. You need to know what the plan is all about, how to follow it. You should attend onboarding sessions, which is where we make you comfortable with all of this. Twice per week, these sessions are conducted. Attend test readiness sessions. Even after you're done with everything, you need to be ready for the test. You need to have a lot more, which you will learn in these sessions. You should watch everything about our learning architecture, which is the three stages of learning. With this little pep talk, I am going to take you all into the next leg of our session today. As I told you, after the warm up section, we're going to have problem solving questions. These are 600 level questions, so higher than where you were in the warm up. But again, you are going to use the very, very same concepts that you built till now. So I'm going to show you the first question. This time onwards, we are going to have GMAT style questions. So you are going to have 5 choices each time. I am opening the poll and still solving is what I'm looking for before I show you the first one. All right, then here's question number one. Ten seconds before I end the poll. All right, then here are the results. So the majority, 48%, went with option C, which is correct. So good job there, but it's not high majority. Less than half of you got this correct then. 17% of you went with D. A and B had it's almost a tie. 8 to 9% of you. E, almost nobody marked E, and 17% did not get to mark the final answer. All right, now this one really, if you actually multiplied 30 with 8.2, calculated the m for yourself, and then saw the remainder when this m is divided by 15, then just mark yes in this poll that I'm bringing in right now. Tell me if you actually calculated the value of m first. So a lot of you did this. You actually calculated the value of m. 61% of you did that. 39% did not. I'm glad for the ones who did not, because actually calculating it is super lengthy. You know what? The same rule we learned, the DNR equation, the power equation I talked to you about, was to help you here. Let me tell you how. M by 30 is 8.2. I can say M is equal to 30 times 8.2, yes, but I'm not going to multiply. What I'll do is I will just break this into two pieces. 30 times 8 plus 30 times 0.2. Now 30 times 0.2 is what will become 6 for me. So it is 30 times 8 plus 6. And my goal is, what happens if it's divided by 15? What is the remainder then? So the goal DNR equation is this here. I've just put my divisor as 15 and the remainder is R, which is what I want to find out. And the only rule I have to take care of is that R is less than 15. Now, how do you use this 30 to make it into a 15? Well, it's super simple. 30 is equal to 15 times 2. So you just break the 30 down. So it becomes 15 times 2 goes with the 8 inside, the 8 that you already had. So it is now 15 times something, which is what becomes your P, plus this 6 that I talked about. Now, since R is less than 15 and 6 is actually less than 15, R equal to 6 works. So the answer is C. I am going to bring in the yes no poll one more time. Tell me if all of you understood this approach, how I used this magical equation to solve a question which you solved using a lengthy method. So I can see again 61% of you are saying that you understood the method. It's very uncanny to have the same percentage again here. We are going to do one or two more examples on this, which is when you will get comfortable with this. So I would not repeat this again, but we're going to do another of the same type. Try applying what you learned in this one on the next question. So tell me you're ready for the next one. Same thing you have to apply. Just learn what you can from this one. DNR equation, use one to get the goal DNR. All right, let's have more votes for people saying they're ready. Okay, then. Here is question number two, everyone. Good luck. Ten seconds before I end the poll. Please mark your answers this time. Don't stay in the still solving block. All right, then. Here are the results. 72% of you went with option C, and it is correct. This is wonderful. Just in the previous question, our accuracy was 48%, and this time it is 72. I'm very happy to see the improvement from one question to the next. That means you're truly learning what is happening here and trying to apply that in questions that come after. So let's discuss this and have the remaining 28% who got this question incorrect on the same page as everybody. So what you have, m is a positive integer again, and m by 15 is 8.2. It's the same story. And you want to get the remainder when m is divided by 30. Again, I'm going to use the DNR equation, and m is equal to 15 times 8.2, but I will not multiply. I will separate this, the decimal part and the integer part. Now, what I want is this side of it, 30p plus r, and it's this r that I want. And the only rule I have to take care of is that r is supposed to be less than 30, right? Now, from 15 times something, I have to go to 30 times something. How will I change 15 into 30? Well, I need an extra 2. I need 15 times 2. That will become 30 for me. Now that 2 will come from this 8. How will it come from this 8? I can just break this 8 down into 2 times 4, right? And that 2 will become a part of 15. So this is what you'll see. It's 15 times 2 times 4 plus 3. What is this 3? It's just 15 times 0.2. Now when you compare it with this goal DNR equation, you can see that R is equal to 3. And I need no changes because it does follow the rule. It is less than 30. And so the remainder is 3. Tell me in the yes no poll if all of us are now clear with this. This is beautiful. 100% people saying yes. This is great. So this is coming up in the last question. 61% if you understood this. Now 100% if you understood this. One more question we're going to do this time. Slightly more, slightly different from this one again, but the same principle. So this time I expect an even higher accuracy. So challenge yourself for this one. All you got to do is apply what you have learned. Nothing new. So still solving to tell me you're ready. All right then. Here you go. Good luck. Ten seconds before I end the poll. All right, here we go. So I can see the majority went with E, 54%. And then the next biggest percentage went with B, 22%. So it's between 3 and 18 then. All right, let's discuss this. The majority is correct, by the way, but 54% of you, 52% of you got this correct. Let's discuss this properly so the remaining 48% gets clear. So it's really actually between B and E. Let's see what happened. M by 15, 9.2. Again, it's the same story. What's the remainder when M is divided by 30? So when you begin writing this, this is how you break this down, the 9.2 into 9 and 0.2. So this 15 times 0.2, this becomes 3. Now what I think is that this is the 3 that you carried on. This is for all those people who marked B. You thought, okay, this is going to be the remainder. Why? Because I can just write this 15 times 9 as 15 times 2 times 4.5. So 30 times 4.5 plus 3. Tell me, all of those people who marked B, is this what you did? This is only for the people who marked B. Nobody else would please respond to this. Only for the people who marked B. Did you break 15 times 9 as 30 times 4.5? Okay, so it's a 50-50 kind of vote. 36% said they did this and 64 said they did not. Okay, so there are people who did this. Well, that is incorrect. Whenever you do the DNR equation, dividend, divisor, quotient, remainder, all of them have to be integers. So this is one rule for all of those people who broke this 9 into 2 times 4.5. This is the rule you were missing. They have to be integers. So now that I know I cannot do that, what do I do? How do I make this 15 times 9 into 30? I know I need a 2 for this somehow. And the 2 can only come from an even number, not from an odd number. So what I'll have to do is I'll have to break this 9 down into 8 plus 1. Then 15 times 8 plus 1 is going to be 15 times 8 plus 15 times 1. Now this 8 is eligible to give me the 2 that I want to make it into a 30. So this will be the 30 times something. And what you have on the right hand side is 15 times 1 plus 3, which is 18. And since this 18 does follow the rule for the remainders, it is less than 30. This is the answer. Tell me now, did you all understand what I did? And I'm also opening the chat box. Tell me, all those of you who marked B, what is it? Where exactly did you falter? So please mark yeses only in the poll, and in the chat box only tell me where you faltered. 79% of you say you're now comfortable with this. Okay, faltered in factoring the 9. 15 times 8. Why don't we simply put 15 times 9.2? Okay, I lost your message. As 30 times 4.6. So the remainder is always this. We're not actually, no, you can't say 30 times 4.6. It is not the DNR equation. You're not allowed to have the decimal as any divisor, as your quotient. But I see what you've done. You've used 30 times 4 plus 30 times 0.6. Try doing that for all of those questions. Right now, the goal is to have 30 times something, and you did manage that with this because you broke it later into a, a multiple with an integer and a multiple with a decimal. So that did work here. In factoring, okay, got the same result. In converting 4 to 9 to 4.5, so many people did this 4.5 thing. I didn't have as many of you saying yes when I asked. Okay, difficulty visualizing these steps. It's all about practice. It will take practice. It's a new method you're learning. DNR approach seems longer when the numbers don't seem too complex. It might seem longer, yes, for now, but you'll see the magic as you keep going on. It's a habit we're building. We don't want to give you different methods for different questions, different approaches for different questions. You might have difficulty in remember so many different approaches. So stay with it, trust the process for more questions to come, and in the end of the session I will ask you again, What do you think? Was it worth it learning this or not? You will tell me yourself. So, right now, all of you just try to make this a part of your thinking process, the DNR method. In case you have any follow-up questions on how the method works, use the Q&A pod, please. Right now, I had asked why people who faltered here, but I did not get those responses a lot. Some of you did tell me, but the others were trying to more give their own approach, which is good, but that is not the purpose here. We are teaching you the approach that will always, always work. Now, here is an overview of these three questions that we did. The first one, you again used the DNR equation. Second, you used it. Third, you used it. It was slightly different in each of them, progressively increasing application. In the last one, when it got the fanciest, where you could not just break 9 down into 2 times 4.5. But then it's the same idea that we are following throughout. Now, for those of you who've understood the DNR approach, and for all of those who have other approaches in mind but have understood the DNR approach, use the DNR approach for all the following questions. You are going to see how this will help you, because now we're going into hard questions. It's 700 plus level problem solving questions. You have to be 200% confident with the concept to really get it. Now, before we solve some more questions, I'm going to give you a few more tools that will make calculations easy for you. So, in this, we are going to build up on our understanding. Look here. Suppose I asked you 31 plus 43 is divided by 7. What's the remainder in that case? One method here, one sequence of doing this would be to actually find the sum, 31 plus 43, and then divide it by 7. If you do that, it's going to be 74 divided by 7, and the remainder is going to be 4. Sequence 2, on the other hand, is you separately divide each of them by 7, get the remainders, and then add the remainders. So 31 by 7 is going to give you remainder 3. 43 by 7 is going to give you remainder 1. When you add those two remainders, you're still going to get 4. Now, here in this example, you might realize, you might feel that both of them are good. It's not really important that I do them separately because adding did not take any time. It's just two-digit numbers, so you can use your judgment here. But let me show you what happens in multiplication. Suppose it's 31 multiplied by 43 divided by 7. This time sequence 1 is actually multiply these two-digit numbers to get 1333, then divided by 7 to get the remainder. Or sequence 2, which is get the remainders separately and then multiply them. So 3 and 1 were your remainders, you multiply them and your answer is just 3. This time, it doesn't take a lot to see that the second sequence is so much more efficient than the first. So it's a huge, huge improvement in the process of finding remainders when the dividend has multiplication or addition in it, or any operations. Multiplication, addition, and powers are what you're going to primarily see. Now, why all of this method works is all based on the DNR equation only. So when you see these slides, you're going to understand. So for example, here I have 31 and 43, right? So I use the DNR equation using divisor 7 on both of them. And then I add them. When I add the right sides of these equations also, it's going to be 7 times 10 plus 4. It's this 3 and this one, the two individual remainders that get added to give you this final remainder. Similarly, in multiplication as well, you multiply these two like this. When you're actually going to multiply each term with each term, you'll finally see that the remainder comes because of this 3 times 1, which is the product of these two. So when you get the PDF, go through this in more detail. Now here is question number 4 that you're going to solve using this idea that we just learned. But again, you know the drill. You first have to tell me you're ready for this. And also tell me in the chat box, how do you feel about this rule? Can you already see and feel how this is going to help your calculations, or you want to see it in questions first? How many of you were aware of this? It's incredible. Amazing. Now we see it. Yes. Not aware, not aware. Okay. Most of you were not aware of this. Some of you were aware also. Very good. Wonderful. Aware but not confident. All right, so now is the time to get confident as well. So here I'm going to open this poll. Just tell me you're ready for this by marking still solving. Meanwhile, I'll keep reading your comments. It's no good approach. Oh, you were not aware. It's a good approach. Okay, yes, it's going to really help you. It's incredible. Wow. Negative remainders will come. Hold tight. All right, so here is question number 4. We were done with 1, 2, 3. Here's number 4. Good luck. Ending the poll in 10 seconds. Okay, here are the results. The majority went with option A. 48% of you marked A, and A is correct. The answer is 0. But there is confusion here. I can see 25% of you went with C, which is that the remainder is 2, and then very few votes for B, D, and E. So it's really between A and C. Let's discuss this. When I'll tell you the solution for this, you'll actually realize something which is very, very important. But let's talk about this. What is the remainder when this expression is divided by 3? Now, a lot of you might have tried to apply what you just learned in the previous slides about, how you can separately find the remainders and then multiply or add, whatever be the operation. Look here now. 24 is divisible by 3, right? So 24 to the power 3 is also going to be divisible by 3. Now, if this expression has one number which is divisible by 3, then obviously the entire product is going to be divisible by 3. And if this is divisible by 3, the remainder is straight away 0. You did not need to do anything. Finding separate remainders, 0 to the power 3 multiplied by 2 to the power 5, and then doing all of those calculations, maybe getting to 32 divided by 3, and that is how I think the people who got it. This is very, very basic. Stick to the core principles. If 24 is divisible by 3, why do you care about what else you see in the expression? What other numbers there are or what powers there are? Stick to the basics. So this one was just a kind of a reality check that don't just try to apply what you just learned blindly. Give everything some thought and apply where it is actually needed. Now that you're more wise in trying to apply this, we're going to go to question number 5. Just mark still solving and I'll show you the next one. Okay then, good luck. Ending the poll in 5 seconds. All right, then here are the results. 65% of you marked C, which is 2, and that is correct, so good. 35% of you still do not get this because a huge majority stayed in the still solving block. 15% of you stayed there. A, B, and D got very few votes, and E got no vote at all. So let's discuss this. Well, this time it wasn't an obvious case as you saw in question number 4. There's nothing that is obviously already divisible by 3. So you had to try to apply the rules you learned. Now think carefully. What is happening is 25 times 38 to the power 3. I can express it like this, right? It's this expression multiplied with itself 3 times. Now the remainder can be calculated for one of them, and then just the remainder can be multiplied with itself 3 times. So what you're really doing is you can consider the power to be outside the remainder. Also, the remainder for each of them is going to be identical, obviously, because nothing is different. So what I'm doing here is I am then going to break the 25 and the 38 into two separate remainder calculations. Look what is written here. It's 25 divided by 3 remainder. That means the remainder when you divide 25 by 3 multiplied by the remainder when you divide 38 by 3, and then you take the third power. Now, in the first case, 25 by 3 remainder is going to be 1 because 3 eighths are 24, and 38 by 3 the remainder is going to be 2 because 3 times 12 is 36. So the remainder is just going to be 2. Now 1 times 2 is 2, and then 2 to the power 3 is 8. Now the rule says that the remainder has to be less than 3 because that is the divisor. So if the remainder right now is 8, you're going to apply the DNR equation one more time on this 8. So when you do that, the final remainder comes out to be 2. So most of you who marked the answer got this correct. So I'm glad. Just tell me in the yes no poll here if you're all comfortable with this now. Even those who did not get the chance to put their answers the last time. Also, tell me in the chat pod how you feel about this method now that you've seen it in application, seen it in action. Awesome, confident, confident. Wow, good. Time saver, makes life easy. Really nice. Yes. What if the power is more? Well, you're going to see that. Right now, because it was just 2 to the power 3, 8 was super simple. But what if it was 2 to the power 1000? That could get crazy, right? You are going to learn that in the very next concept. I'm glad somebody asked that and led us to that. Okay, so here now is an overview of what you did in these two questions. Your core idea here was that you can separate addition, addition, multiplication, and powers, and then you can find remainders separately. Now, what I'm going to do is I am going to introduce you to negative remainders. Somebody already asked about this, and now we know you are going to really need this as your powers get larger. See, let's understand this through examples. And before I even do this, remember the rule I told right in the beginning. The remainders have to be non-negative. They can be 0 or otherwise they're positive, but always less than the divisor, of course. So this is a rule forever. So negative remainders already, although we're doing them here, will not be the final answers that you leave in your question. This is a tool to make life easy, as we just did with the previous method. This will make calculations fast, but ultimately you will have to translate this negative remainder back into its positive version. Let me tell you how. So first, let's consider this very simple example, 5 divided by 2. So the remainder is 1. I can use the DNR equation. 5 is equal to 2 times 2 plus 1. I can also express this as 2 times 3 minus 1. Now, when I express it this way, then this minus 1 is the negative remainder I'm talking about. So it's really simple. It's just the same story. In this one, it's something extra, something you add, and here it's something you subtract. Let me show you another one. 8 divided by 3. So the usual DNR equation is 3 times 2 plus 2. But think of the next multiple. Instead of 3 times 2, if I take 3 times 3, it's going to be 3 times 3 minus 1. So the negative remainder is minus 1. Now, in this first example, the plus 1 and the minus 1, numerically they're both the same. Magnitude wise, they're both 1. It's just that the sign is different. But when you look at this second example, the positive remainder is a plus 2, while the negative remainder is minus 1. And when it comes to powers, say the power was 1000, 2 to the power 1000 would be crazy work. But minus 1 to the power 1000 would be beautiful. It's just 1, and that'll be your final answer. This is where negative remainders are going to help you. Whenever the powers are huge and you get a minus 1 as your negative remainder, it's going to make life super easy. But as I said, even after your final stages, if you're left with the negative remainder, how do you change it back to the positive remainder? Well, all you got to do is add the divisor to this negative remainder and you're going to get the positive version out of it. For example, if you see this one, the one with 5, the negative remainder is minus 1. Just add the divisor to it, which was 2. So negative 1 plus 2 will give you the positive remainder. Similarly here, negative 1 plus the divisor, which was 3, will give you 2, which is the positive remainder. Now here is the theoretical, these are the steps that help you convert from one form to another. So this first one here, we started with the negative case, and how we converted was we added and subtracted the divisor so that the equation does not change. And then you just rearrange your terms a little. You take the subtracted 2 here, you take 2 common, and then this time it ends up with the original DNR equation with the positive remainder. So this is just to understand how this happens. But you need to know how to go from negative to positive. Now, same story we've done here for the 8 case. Start with the negative DNR equation, add and subtract the divisor to it, rearrange your terms, and you're going to get the positive DNR equation. This now is a very powerful tool. I already told you how it's going to help you with with large powers. Let's try this in action with a question. That is when you'll truly be able to appreciate this. So I'm going to bring in question number 6 here. You just have to tell me you're ready to apply what you just learned here. When you do so, try to consciously think about what would happen if we didn't have negative remainders. How would positive remainders make life difficult for the question that's coming? That is when you'll truly be able to appreciate this method. Okay, here is question 6. Good luck. Ending the poll in 10 seconds. All right, let's see the answers. So 68% of you marked option D, which is the correct answer. So good, the majority got this correct again. But a lot of you, 14%, went with C also. Let's understand this. And then there were negligible votes for A, B, and E. So let's see. What is the remainder when this expression is divided by 3? If you took the learnings from a previous question seriously, then you would understand that this first expression here is again always going to be divisible by 3 for the simple reason that you have 24 in it. So if the first expression here is always divisible by 3, then the remainder, when this whole thing is divided by 3, has to be 0. So really, it comes down to this second value here. So here's what I mean. You separate these expressions like this. This becomes your first remainder calculation. This is the second one. And from the first one, you just get 0. From the second one now, what happens if 17 is divided by 3? The remainder is 2. Now, for all of those who would say it is 2 to the power 7, how would you calculate 2 to the power 7? Well, it would take a while, right? So I'm not sure if the people who marked D actually thought beyond this, or you just saw this 2 before doing anything else and just marked 2. Let's discuss this completely and make sure that you got this correct for the right reasons. Now, since 2 to the power 7 would be quite a calculation, we would try to think in terms of negative remainders. And negative remainder here is minus 1 because I can write 17 as 3 times 6 minus 1. And then when I take the remainder as minus 1, then minus 1 to the power 7 is sweetly calculated. It's just minus 1. Finally, all you need to do is convert this negative remainder back into its positive version. And how you do that is add the divisor to it. So minus 1 plus 3 gives you 2. Tell me in the yes no poll, everyone, did you understand this completely? Anything about the method, please ask in the Q&A pod. Feel free to ask questions. Since I see just a 50-50 response here, 50% of you are comfortable, 50% are not, that is maybe because you're seeing negative remainders for the first time. I'm also opening the chat box because of this kind of confusion that we have here. Tell me in the chat box, what is the biggest concern you have here? I'll try to explain this again. Should the remainder always be positive? Positive or 0? Yes. How to convert into positive? Just add the divisor to the negative remainder. A and D both are correct. No, you cannot leave the final remainder as negative. I said it has to be 0 or positive. Can you show how to solve without negative remainders? You can take 2 to the power 7, actually calculate the value of 2 to the power 7, which is 128, then divide 128 by 3 to get the remainder. Why we use negative approach when we could answer by positive? Because positive required a lot of more work. 2 to the power 7, you had to know the power. I'm lost at 17 by 3 equal to 5R2. Yeah, so the remainder is 2. When you divide 17 by 3, the positive remainder is 2, which is what we did here. But then we had to do a 2 to the power 7. And just to avoid that huge power, we changed it to a negative remainder. If we divide 17 by 3, well, everybody did that and you got 2 as the positive remainder, but you had to move on. What if we don't get minus 1? What if we get minus 2? Well, that is not going to happen in negative remainders. And if it does happen, then the power is not going to be too high. Suppose your divisor is 8. Then with a positive divisor, with a positive remainder of 6, the corresponding negative remainder would be minus 2. You would definitely go for minus 2 in that case. And calculating a minus 2 to the power 3, for example, would be easier than calculating 6 to the power 3. Negative remainder approach is very good when remainder is minus 1. I just answered that. You use the negative remainder approach whenever that gives you the smaller magnitude. How you solve 2 to the power 7? Well, 2 to the power 7, I know the value is 128. Because I know it, I could do that quickly. You might have to actually multiply this. Can we ignore the power? No, you can't ignore the power. You have to take everything in the question. So I answered a lot of questions here, tried to do as well as I could. Let's hope that this one helps you in the next one. 128 cannot be the answer. Remember the rules we did. The divisor is 3, so the remainder has to be less than 3. How can it be 128? Remainder has to be less than 3. All right, with this now, I am going to take you to the next question where you'll apply the same idea again. This time, now that I've answered so many of your questions, I hope a lot of your doubts were resolved and you'll be able to do better on the next one. Please tell me you're ready for the next one by marking still solving, and I'm going to show you problem solving last question, question number 7. Okay, then. Good luck. Ending the poll in 10 seconds. Okay, then let me show you how you people responded to this one. 84% of you went with option E, which is the correct answer. So good, you have a high majority this time, high accuracy this time. Just 4% votes we got for C, no votes at all for A, B, D, or E, and the remaining 12 stayed in still solving. So this is actually a great, great majority this time. Let's discuss this now. Again, you had to break this down into pieces. The first one here is this expression 24 to the power 3 times 38 to the power 5, and the second one is 17 to the power 7. Yet again, since 24 is definitely divisible by 6, this entire expression is divisible by 6, and so the remainder is 0. Now for the second one. If you think of the positive remainder, it's going to be 5. 6 times 2 plus 5. And then think about doing 5 to the power 7. I would not even do this time. I knew 2 to the power 7, but I don't have 5 to the power 7 on my tips. I will now go to negative remainders. That blessing gives me minus 1 as my negative remainder. And then minus 1 to the power 7, just minus 1. Final step is to convert this negative remainder that I have into its positive version, which is by adding the divisor. So minus 1 plus 6 is 5. Tell me now in the chat box, how do you people feel about this? We are not ignoring any powers in the this first expression also. We're not ignoring powers. Really what happened was 24 is divisible by 6. The power, the remainder there is 0. So it just becomes 0 to the power 3. Now, if it is 0 to power 3 or 30, doesn't matter, right? That is why it doesn't matter at all. If the question was 17 to the power 1000 divided by 7, how to do it? It's still going to be the same thing. If you do it by 7, the positive remainder will be 3 and the negative remainder will be minus 4. So obviously 3 is the better one, but they are not going to ask you 3 to the power 1000. As I said, they will only keep it in calculable limits if the negative remainder comes out anything other than minus 1. Otherwise, it's just going to be minus 1. Feeling good, simply awesome, made it super easy, amazing, great. Can we have a question where the power is even? Well, if it was even, say it was minus 1 to the power 8, then the remainder would straight be 1. You would not need to do any final conversion from negative to positive. That's it. What about, no, you would not add the divisor to it then. You only add the divisor to convert negative remainder to positive remainder. Otherwise, it stays the same. Okay, I'm glad. This works for exponential addition. I'm not sure what you mean, exponential addition. If you have exponents on top, we just saw how this works. Okay, any follow-up questions, please post them in the Q&A pod. I am going to now talk about an overview of these questions. These two last ones were about negative remainders. Now, before we go to the first three questions, remember 8, 9, and 10? This was all a preparation for that. From all that you learned till now, negative remainders, adding remainders, multiplying remainders, DNR equation, tell me your biggest takeaways in the chat box, and then I'm going to take you to the last set of questions. Negative remainders was the biggest takeaway for someone. Okay, biggest takeaway is negative. Okay. Apply constraints, trust the process. Yes, all the methods were good takeaways. Do you guys now feel the DNR equation is magical? Because we're constantly just using it, whether in negative remainders or positive remainders. If you did not learn the method earlier, it would be hard to take it to the negative case. We will review the first. Yes, we're going to do the first three questions now. We are going to do this. Only if final remainder is negative, we convert. Yes, yes. Biggest takeaways, negative remainders. Perfect. Good. All right. So now I'm going to show you the first question we did, the first challenge question. That was question number 8. This time I will tell you how your accuracy changed as a group. Just mark still solving to tell me you're ready. You'll be very, very happy to see the change in accuracy if you've taken everything you've learned and remember to apply it here. Let's take up the numbers for people marking still solving. That is only the active group I consider when I take care of the time. It's important. Otherwise, you might feel you ran out of time, you didn't have enough time. If you want to actually participate in the time deciding process, mark still solving. All right, here's question number 8. Good luck. Ending the poll in 15 seconds. Panic, use these 15 seconds wisely. Okay, then here are your responses. 51% of you went with option A, which is the correct answer. So good job. Last time you people voted for this, 28% of you had voted for A. So it's almost double there. The double of 28 is 56. So very good. The group has improved. Last time the majority was with C. We had, I think, 31% of you with C, and it's the same now. So even now the battle is between A and C, but I'm glad that this time the majority is on the correct side. Last time the majority was on the incorrect side. So give yourself a pat on the back if you changed your answer in this second attempt. Now for all those of you who marked C, what I feel is you did not think through before talking about anything else. I think it's just the fact that you thought in statement one, you did not know the value of m, that you thought, oh, I can't calculate the remainder if I don't even know m. Because if I don't know m, I don't know p. And if I don't know p, what am I going to do? It's all unknown. So tell me, all of those who marked C, is this how you thought about the first statement? Did you reject it because you didn't have m? Yeah, I thought so. So majority is saying that yes, this is why they rejected the first statement. 85% already. Well, this here is a key learning point for you then. Don't reject something just because you think it is not sufficient. Give it its due share of work. Analyze it. Work on it. Let me show you what you have to do here. So remainder when p is divided by m, right? Now p is m plus 1 to the power 8. And this is what I'm dividing by m. If you look at this sum here and then this power, now you know you can separate all of this for remainders. So you can just put the power outside and think about just m plus 1 being divided by m. Now, when m plus 1 is divided by m, what are the separate remainders? First one, when m is divided by m, remainder is 0. When 1 is divided by m, remainder is 1. So 0 plus 1 is 1. So it's 1 to the power 8, which is just 1. It is sufficient. Write in the chat box, how do you feel about this? What is it that you're learning from this one question? Everybody who just rejected statement 1 because they thought they needed the exact value of m. Don't reject something before you try. Try it out. Yes, such a blunder. Don't be too quick at answering. Why did we take the power out? Why? Because we can simplify finding remainders that way, right? Separate the powers, separate the addition, separate multiplication. Why 1 by m is m? 1 by m is not m. We are finding the remainder when m plus 1 is divided by m. You can also think of this as any number being divided by exactly one number less than it. 6 divided by 5, or 11 divided by 10, or 3000 divided by 2999. Remainder has to be 1 every time. Shame. How can we take the power out of bracket when denominator? You have to really watch the recording again, go through the PDF that we send you, because this is something we've been learning in the previous examples. You are finding remainders separately. It's not taking that kind of a power out. It's not a denominator here. M is the divisor, and m plus 1 to the power 8 is the dividend. It's not numerator denominator. Okay, so I'm glad some people did get the correct answer the first time. So very well done. All those of you who are getting confused with this, just actually think hard. What is the use of m greater than 1? Well, if m is not greater than 1, suppose m is 1, then this one is going to be 2 divided by 1, and the remainder will be 0. So in that case, the remainder is not going to be 1. So we didn't want that extra case to be there. All right, so now that you see the first statement is sufficient, second one anyway does not make sense. It's just telling you M. It's not telling you what P is. It's just saying P is something which is divided by 8. Tell me the remainder. You have to know the dividend. That's why second statement is could not be sufficient, and nobody marked that anyway. So it was only about the people who went for C. All right, so I hope everybody is absolutely clear with this. This was really not that difficult if we did not give up by just looking at the question. So here's a good learning for you. I'm going to take you to the next question. Mark still solving to tell me you're ready for number 9. There you go. Good luck. Ending the poll in 15 seconds. Okay, so here are the results. 42% of you marked A, and A is the correct answer. So good job here. The majority got this correct. Last time, 27% votes were for A. So then that has definitely gone up. So 27 to 42 is how much? 15%. 15% more people now got this correct. I can see confusion here between C and D then, next options, and B and E barely got votes. So let's discuss this nicely. Slowly, I'll just keep this broadcast so you can keep seeing how you people responded. Let's think about it step by step, okay? Step one is to analyze the question statement completely. So n is a positive integer. What is the remainder when 38 to the power n squared is divided by 13? So this is how you express it, okay? So you just want the remainder in this case, and n is something positive, some positive integer. Now you know you can separately find the remainder out for 38 first and then put the power on top. So this is how it looks, right? 38 divided by 3, the remainder for that, and then you raise that remainder to n squared. Now, the positive remainder, if you see, is 12. 13 times 2 plus 12. But when you see the negative remainder, it's minus 1. If I took the positive one, it would be 12 to the power n squared. And this time I don't even know the power. I anyway didn't want big numbers inside these where I had to calculate powers, and now I don't even know the power. So I definitely don't like this. But the negative remainder is so sweet, it's just minus 1. So it's minus 1 to the power n squared. Now it really depends on two cases. This n could be even, could be odd. If n is odd, then n squared will also be odd. The square of any odd number is odd, right? So in that case, the remainder will be minus 1. The final remainder will be minus 1, which you then will just have to convert to the positive version by adding the divisor 13. So in that case, the remainder would be 12. But if n is even, then n squared will also be even. So minus 1 to the power an even number would just give you the remainder as plus 1. You don't need any further conversion or anything. So really then the remainder that you're looking for depends on what? It depends on n, whether n is even or odd. So just odd, even becomes your final question. This is what will decide whether any given statement is sufficient or not. Now here the first statement tells me that n leaves no remainder when divided by 4. Well, if it is divisible by 4, then it has to be even, right? To be even, you just had to be divisible by 2. You didn't even need a 4. So then you got it. So if it is even, then definitely the remainder is plus 1. So so statement 1 is sufficient. So for all those of you who marked C, you thought that statement 1 was not sufficient alone. And all those who marked B or those who marked E, all of you thought statement 1 was not sufficient. So, only for you guys, write down in the chat box where did you falter. Please, only the people who faltered here, who did not think the first statement was sufficient. So, everyone who marked B, C, E. The value of n. You were confused because it was an unknown. So you maybe could not make the cases even and odd to get a definite value. Yeah, everybody thought about how to get value. Anyway, n odd or even square, it will always be positive. Yeah, we don't care about it being positive. It's only about being even odd because that is how we'll decide whether the final remainder is positive or negative. Shouldn't the remainder be 1 if n is even? It is 1. That's what's written here. Remainder is plus 1. Forgot to apply negative remainder. Well, learn and apply then. Okay, alright. Okay. It says n leaves no remainder when divided by 4. Yeah, when divided by 4, it leaves no remainder. That means it is divisible by 4, and that's how I got that it is even. Alright, so this is how we discussed the first statement. I hope everybody is clear now. Let's move to the second statement, which says square root of n is only divisible by 1 in itself. What can such a number be? Something that's divisible by 1 in itself? That number is prime. So square root of n is prime. That means n is the square of a prime number. Now it could be 2 squared, 3 squared, 5 squared, anything. Now if it is 2 squared, it's even. Otherwise, it's odd. So even now, I have no idea about whether n is odd or even. And that's why I can't say whether my remainder is 12 or 1. So the second statement is insufficient. You cannot get the remainder here. Tell me if you people understood the solution here. I'm opening the yes no poll. More votes, please. Tell me, are you comfortable with the solution? Did you understand what happened? You should not be confused with any step here. Ask in the Q&A pod if you have any confusion. All right, so I see 80% of you are now comfortable with the solution, which is very good. We're now going to go into question number 10. Just tell me you're ready for it and I'll show it to you. Let's have higher numbers. Right now, half of you are saying you're ready. And some people are also marking C and D. You don't even know the question yet. Just mark still solving to tell me you're ready for the question. Okay, then. Here's number 10. Good luck. Ending the poll in 15. All right, then here are your responses. The majority went with option D, which is correct. Good. So 49% of you got this correct. Last time you voted, I had 30% votes for option D. So it has definitely gone up. Now, if you see the results, 22% went with A. That means these people just faltered at one step. They did not understand that the second statement was sufficient. All those who marked B, you understood that the second was sufficient, but just missed the first one. So really the problem is with the C and E. So the maximum need to understand this is for people who marked C and E. So let's think about this, and very few people did that, so we're good here. What is the remainder when 4m is divided by 16? And then you have two statements. So first let me think about the question statement only. 4m divided by 16, I need the remainder. So if I write that according to the DNR equation, then this is r that I want to find out, and all I know is r has to be less than 16. So here how I've written it is less than equal to 15. If it's less than 16, it can be 15, right? And it has to be greater than equal to 0 as well. This is all. The question stem tells me nothing at all, nothing. And then let's look at the first statement. It says m leaves a remainder of 4 when divided by 32 to the power 32. So I can use this to write the DNR equation like this, right? Now think about it. This is m. What I have information about is 4m. How do I connect the two? Well, I'll just multiply this second equation from statement 1 by 4. So then what I'll get is this 4 times this entire expression. Now, this will become m for me, 32 to the power 32k. This is my m. What I actually wanted was, I'm sorry, 4m is anyway on the left hand side. From the right hand side, I need 16q. So I need this to be a multiple of 16. Now think, 16 is what? 4 times 4? And I already have a 4 here. So I just need one more 4. You can definitely get that 4 from this 32 to the power 32. Even 132 is enough really. So what I'll do is I'll just take away 132. It's 32 times the rest of them, 32 to the power 31. Now this 132 is going to give me the 4 that I want. And then the remaining 8 I've kept here. You don't need to bother about what this exact value comes out to be. It's just 16 times something. So let's just call that 16 times P. And on the right hand side, this 4 and this 4, they get multiplied to give you 16. And since our 16 then, what our question was, 16 q plus r. It has to be 16, a multiple of 16 plus a remainder, which is less than 16. So if somebody would just leave it here, then they would think, okay, the remainder is 16, but that's not possible, no? Because it has to be less than 16. So you apply the DNR equation one more time, and that way remainder will be 0. Or you can just take 16 common. So you'll see it is 16 times something plus 0. So the first statement does give us an answer for what we were looking. It is sufficient. So all of those people who marked B or C or E, tell me the step you faltered if you exactly know where. Otherwise, then if you could not apply the method, tell me so. The DNR equation again is the method you had to go for here. After this, I am gonna go for your internet might be a problem because I can see my connection status as excellent. Can we simplify 4m divided by 16 to m divided? No, 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 no. I'm glad you asked this. So you cannot cancel it out like that. Nope. Could not solve till the end. That was the problem. Okay. Why can't we cancel? Try that for an example. Say, take a number. Say 16 divided by 6. The remainder will be 4. But if you cancel it, 8 divided by 3, the remainder will be 2. You're changing the remainder. You can't do that. Okay. I made it, yeah. So you did that, and now that I gave you numbers, it's not possible. Do we need to solve it till the very end? No, you don't need to solve it till the very end. The moment you realize that you will be able to get it in the DNR form, so 4m equal to this step itself, we give you the entire analysis to show you till the end. But here, if you can just see clearly that you will be able to make this into a 16 times something, it's just this 4 times 4 that will give you the remainder for sure. That's a good question. Okay, all of us, let's now go together into statement 2. Let's analyze this. Statement 2 says m cube, m to the power 3 is divided by 16. So if m to the power 3 is divided by 16, then definitely m will have a 2 in it. Why am I saying this? Because if m cube is even, then m has to be an even number. And if it's an even number, then it will have a certain power of 2 when you try to write down its prime factored form. So if this is m, then this is m to the power 3. Now, I know m to the power 3 has a 16 in it, which is 2 to the power 4. That means this power, 3a, is at least 4. It can't be less than 4 because I know I have 2 to the power 4. So 3a greater than equal to 4 gives me a greater than equal to 4 by 3. But because it's an integer, minimum a has to be 2. So if minimum a has to be 2, then using it here, I know my m is equal to this. 4 times something. So m is this. You were interested in 4m, remember. So if m is 4 times something, 4m is 16 times something, no? So 4m is definitely divisible by 16. So second statement as well is sufficient. Now tell me, all of you who marked A or C or E, what did you miss? M to the power 3 divisible by 16, then m should be divisible by 16. What? No. If m to the power 3 is divisible by 16, why does m have to be divisible by 16? Tell me the step that you did not understand. Explaining the whole thing again would be too lengthy. Tell me the exact step where you're confused. I'll try to go over it meanwhile. M to the power 3. Okay, so many people asking it. I'll have to repeat it. Okay, look. M to the power 3 divisible by 16 means m cube is an even number. That means m is an even number. So that answers this question. Why does m have a 2? So if m is an even number, then its prime factored form will definitely have a 2 in it, like this, with some power. Then from this I found m to the power 3. Because it has 2 to the power 4, this 3a has to be at least 4. It can't be less than that. That gave me the value of a, and that gave me m. After I got m, 4m was really easy. Just had to multiply both sides by 4. Now, I hope you understand what happened here, how 4m is definitely a multiple of 16. Now, since each statement alone is sufficient, the correct answer for this one is D. Minimum 2 value, because a is greater than equal to 4 by 3. The very first integer that you have after this is 2. Now, okay, all of you understood this. I understood this. There is no way I'd be able to do this. Don't say that yet. You're just doing it for the first time. Relax. With practice, you will see yourself doing this. Use the PPT, use the recording that you get. Internalize the method. It will happen for you. Don't worry. Tell me now, how did you guys feel about the session? How do you like this? What all did you learn today? Things that you now know you have to work on, things that are better now for you. Tell me. All right, tough session. Awesome. Yes, it's a problem area for many people. They do find it difficult. But remember, GMAT quant can be mastered for sure. Just how you've mastered this topic that we learned today, you can do all of it. Nothing is going to be difficult for you if you just, decide to do things the right way. Yeah, these sessions happen regularly. Whether you are a student or not, you can attend these sessions. I can't believe I was even able to attempt the last 3 questions. I feel like I unlocked something in my brain. I love these comments. How many concepts need to be learned? Well, there are many, many concepts you need to understand, you need to practice. I'm very glad you guys liked this. People before you have tried the course, done things the right way. Like Krish, you see here, he was stuck. He could not improve on data sufficiency questions. He used to just fall into these traps. Remember the 24 question that you saw? When 24 is always divisible by 3, but you tried to apply the method. All those little traps, they happen. There are people who really think they're already good with quant, but when it comes to doing GMAT questions, they do get confused. You need a structured approach. Just how Krish had to change the approach to really see the difference. It was a good session, good experience, communication skill convincing. Thank you. Change in approach towards difficult questions. Yes, you need to change the approach and then set an approach. Working with remainders was amazing. Yeah, especially the negative remainders, right? I learned that the first time. I loved it. I was like, how is this magic happening? Now, today, I can explain it well because I understand it well. Leonardo here was unable to cross Q45, so he's one of us. How do these things suddenly change for people? They accept methodical approaches. Today, you learned so many methodical approaches, you just have to internalize them, you have to use them. This is the first time I understood remainders concepts. See? And now that you've understood the concept, try practicing. Practice it before it gets rusted again. Practice more questions on it. Okay, very insightful. Thank you. So use analytics that you see on the platform. Right now, I was one person telling you where you're faltering. The system, the e-GMAT portal, you have a system where it'll actually pinpoint the errors you're making, your problem areas. It's like, no, 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 you are always missing this point. You'll know what to work on. No, then you have to have somebody telling you where you're faltering. You had me today, but then there are so many things you need a proper system for that. Here's Mazibar went from a Q30 to a Q45. Isn't that magical? Just 20% people scored below him earlier, and now when he ultimately did it, 59% of the people scored below him. So everything happens if you just prepare the right way. This is Q38 to Q50. You know the highest score in quant is Q51. So going from 38 to 50 means you've done a lot. You focused on learning, obtained accurate estimate of ability. Today now you guys must have understood more about yourself in terms of this topic, in relation to this topic. Follow this. Whatever you learn today, don't just let it go. Focus on learning, adapt all of these good habits, make them a part of your journey, and it is going to happen. I loved conducting this session today. See you again soon in another session. We are going to keep doing sessions, as you know. I told you about the ones happening next weekend. I'll see you on another one. Happy learning.